Can I have your attention, please? Thanks. Okay, I got some questions about the schedule, and I realized that the combination of the content being on Canvas and the schedule being only the official VU roster schedule is not a very good combination. So I rearranged the Canvas website from topics just to weeks. I think that makes it easier because the topics and the weeks don't align completely, and most students want to know more what is happening when than exactly to what topic it belongs. So this is now the content of the Canvas website. I hope that clears things up. So we're now in week 3. Right, and so
oh, you might have it there, but is assignment 4 going to be due at the end of week 4?
I'm going to explain that. Yeah. So the course is 4 weeks, right? And the first 3 weeks are all organized in the same way. So these 2 lectures on Monday, a lab session, a lecture on Wednesday, a lecture on Thursday, a lab session. You do an assignment during the week that you turn in on Monday. Right? That's all the same for the first 3 weeks. The 4th week is going to be different. So the next week, it's only doing the assignment 4 that I still need to put up, and there's 1 lab session to do this assignment. And from a number of hours that I expect you to spend on the assignment, but assignment 4 will be smaller than the other assignments. It will be kind of a look back on what you did in assignment 1, 2, 3 type of assignment, and try to improve on all the feedback that you got, but also reflect a bit yourself on what you have learned. So it's a different type of assignment than the first 3.
So it's basically a recap.
It's basically a recap assignment, yes. And then the deadline for that assignment will be Wednesday evening, and then you have all Thursday to prepare for the exam on Friday. Right, and there will be no lectures, so you will have plenty of time instead of the lectures to both work on your assignment or to prepare for the exam. Okay, this week is just a normal week like the first 2, right? So I do a lecture today that you will need for assignment 3 that starts today. Victor de Boer will do a lecture in the afternoon about web science with topics that will come back at the exam, but not at in the assignment. Then on Wednesday I will do a course on web evaluation. Will also come back at the exam. It will also be handy for the 4th assignment. And on Thursday we will do also kind of a recap lecture where we tell you exactly what we expect for the exam, how to prepare for the exam, and I also like to use this for a round of feedback. Right? So if you have feedback for the course, try to think about it ahead of time, so that you can share that on Thursday. So that's going to be the schedule for this week and next week.
Is assignment 4 only going to be released at 10 AM next Monday, or can it be released?
No, it's going to be released earlier. Yeah. So if you already finished assignment 3, then there will be plenty of time to start earlier with assignment 4 in case you want to do that. Okay, so I did not release anything about assignment 3 until today. There are all kinds of tutorials I want you to make. I did not ask you to do them yet, because all the things we're going to do today on assignment 3, it's all really server-side, right? And last year I asked in the weekend people to prepare for these tutorials while they were doing assignment 2 on the client side. And, quite a couple of students got completely confused about mixing up client side and server side. So this here's another experiment. I tried to be silent on all the server side stuff until after the deadline of assignment 2. So we had the deadline of assignment 2 an hour ago, right? Who got really in trouble with assignment 2? Who thinks you did what was okay? So where were the troubles?
Oh, no, there were no troubles.
There were no troubles.
We thought you said who did okay.
Okay, so this was yes for okay. Okay, good. because there was a lot more programming in assignment 2 than in assignment 1, right? So I want to check if that caused troubles. One thing I noticed during the lab sessions that I got questions from students that their code didn't work, right? That I can understand, and they didn't know why that was, what causing these troubles. And I saw pieces of code in JavaScript of 20, 30 lines of JavaScript where I thought, okay, none of this works, right? Not even a single line. So if I would do that myself, right, I would start by making sure that I have a single line of JavaScript that prints to the console, hello world, and make sure that works, right? And I think a lot of you just didn't do that step, right? You start with a large piece of JavaScript that contains like 25 errors that you don't know of. And every time you fix one, it doesn't make a difference because there are still 24 others that make nothing work. So be more conservative, right? Don't overestimate yourself. This is a new topic. You can start small, do baby steps, and make sure that all the little steps work before you go on. So that's one observation. And the other observation is reading and trying to understand error messages. Right? I've seen a lot of students that got a very, very helpful error message in the console, and the students think it's not important. Well, the error message actually tells you what is wrong, and if you would just fix what was wrong, reported in the error message, the problem was solved. Right? So error messages are often important. And when I see an error message and I think it's not important, because I know what I do wrong, I'm going to fix that first, but if that still doesn't work, maybe there's one other thing I try, but if I don't know what is wrong and I see an error message, then okay, maybe it is the error message that is the problem, and maybe I do need to solve that first before I go on. So I've seen a lot of people where the first error message was that the jQuery loading failed, right? And then they had a lot of jQuery code that didn't work. And somehow they thought, okay, the fact that the jQuery loading failed was not important enough to fix it. Right? So there, you really need to look at these error messages, and either you need to understand and be very, very sure of yourself that it's harmless, or be safe and just try to understand what's going on and fix it first. And if you don't know what's going on, right, ask, because maybe that's the key hint that makes your program work. Okay. Back to the deck. So assignment 3 will be about designing and documenting your own server. So the documenting part is important. Right? This is an assignment where the coding will be done in Python. But if you do the assignment really, really well, right, and none of your Python code works, you can still get a pretty decent grade, right, at least a 6. Even if none of your code works, just by doing all the documentation and explanation right. So make sure that if you get stuck in coding, right, and that you spend a lot of time in bug fixing, don't forget to do the documentation, because it's worth a lot of points here. And also, doing your documentation first and then do the coding really helps in the coding. Because if you have your documentation correct, that means that conceptually you know what you're doing, right? And then you only need to implement it. And if you're doing the coding while you're not sure what you're doing, it makes the coding a lot harder. So I would focus on the documentation for this assignment and then do the coding later. So we're going to build a web server. And the web server that you're going to build will be a lot like the web server that you have been using in assignment 1 and 2, the one that we made available. Right, so now we're going to switch sides. In assignment 1 and assignment 2, you were building the client and we were providing the server. And now we do the other way around. You provide the server, and of course you also need to play the client to test your own server. But the focus will be on the server. Okay. So remember, we had this client server architecture in the web. And the client so far has been the web browser. We're going to see today that there are also different clients, and one of them you're going to use also in the lab and in the assignment. And the web servers. So far in the assignments we've been ignoring these, right? And now the focus will be on the server. We've seen that a client views a resource. A resource is anything that has a URI on the web. And the resources are served by a server. We have seen content versus style, right? That if you do the content in HTML and the style in CSS, you can clearly separate this. You can have the same story for separating the content and the programming, right? You do the content in HTML and the programming, client-side programming in JavaScript. And you can keep that nicely separate. We've seen some of the HTTP server basics. We've seen all these things that a web server needs to support. That makes it more complicated than you would think in the beginning. And we have looked how it serves static and dynamic content, which is basically all you need for assignment 3, except for one key ingredient, and that's REST, the REST architecture. And the REST architecture will be the main topic of this lecture. It's the key technical success factor of what made the success of the web. And it's also the key architectural style that you need to use in assignment 3. So we have looked at the success of the web before, right? And if you compare the web with other huge IT projects, it is really a remarkable project, right? It's by far the biggest information system we've ever built. And if you compare it to other big information system projects, right, all the other projects usually fail. If you look at all the big projects of the Dutch government in the last like 10, 20 years, right? From the top of my head, I cannot name one success story. They're all failures. And it's partly because of organizational reasons, right? Partly of political, social, economic reasons, but there are also technical reasons. And I think one of the technical reasons why the web is a success is in the very incremental, flexible architecture. So the fact that the web did not start from scratch, but built on top of already successful infrastructure, right? So the internet was already working well before the web was invented. And the web didn't try to replace it, but build on top of it. TCP, IP was working well. The DNS, the domain name service, was working well. And the web took advantage of that, instead of trying to make something better. So that's one key argument. And the other argument is that within what it built on top, so if you look at the web infrastructure built on top of these successful stories, there are some very basic rules that the initial web architects applied. And after that was already a success, people started to analyze them, and these rules are now, after the fact, called the REST architecture. And this is from a survey that's very old, 2013, where web developers were asked about the most important technology they used on a day-to-day basis. And REST was like 91%, right? And if you try to find more modern things, you cannot find it anymore, because REST is now so commonplace, it's not even mentioned as a technology anymore, because everybody is using it, right? So it doesn't show up in the polls anymore. And the key figure behind REST is this guy, Roy Fielding. You might recognize his name because he's also the co-author of the HTTP specification. So if you were looking for the HTTP authoritative reference, then his name was on there. He was also co-founder of the Apache Foundation, that is doing all these open source, web-related open source projects. And he did, I think, that is now known as the first PhD thesis on the web in 2000, where he describe the key principles of what made the web work in his thesis. And he named these principles REST. And I've grayed out what REST stands for, and in this beamer is not even visible. It stands for representational state transfer. You can forget that immediately, right? Because the acronym is very well known. What it stands for, I think very few people understand. And if you are designing an architecture that complies to his rules, then these architectures or services are known as RESTful services or RESTful architectures. And your assignment 3 will be to develop, to design a web server that is RESTful. So you should comply to the architectures, to the principles that Roy Fielding described in his thesis. So what are these principles? First, maybe the key rule on the web: everything that is can be seen as an information source, it's called a resource, and it has a URI or a URL, IRI. Right? So something that doesn't have a URL is not on the web, and if it has a URL, then it's on the web. That's the first principle. And clients and servers that want to communicate over the web, exchanging information and resources, need to know 3 key things. One is, of course, the URI. Right? So if you want to communicate the homepage of the faculty, the client and the server need to agree what is the URI of that homepage. If they cannot agree on that, then we are in trouble. They also need to agree on the actions that are allowed. Right? So if the client doesn't know it can do a GET on this resource, or if the server doesn't accept the GET, then we're also in trouble. So there needs to be some agreement on what HTTP messages can you send, and can you expect they'll be correctly handled by the other side. And then you get something back, and you want to know what the format is that you will get back, right? So typically for the home page, you would expect the result to be in text HTML. If the server cannot serve text HTML while the browser expects text HTML only, right? Then we have a problem. But of course, for other resources, right, it can also be other types. But there need to be agreement on from both sides on what the format is. So if you send an image and the browser cannot display GIF, right, then there's also a problem. So these 3 things you need to know. But basically, that is all there is that you need to know. Right? So there's also a lot of things that you don't need to know, which make the web work. So one thing that you don't need to know as a client is on how the server generates that representation. Right? So we have seen that if you generate an HTML page on the fly on a server, there is nothing the client needs to know about that, because the client still sends a GET request to the server and gets back the reply. Same thing from the client's perspective, if it's static or dynamically generated at the server. Client doesn't need to know. And vice versa, the server does not need to know what the client will be doing with the resource. Right? So the server doesn't need to know if the client is a browser that wants to display the document, or if the client is a web search engine crawler that wants to index the HTML for retrieval purposes later. The server doesn't care. It just gets a GET request and replies, and what the client does with the resource, it doesn't need to know. And if in between there are proxies or caches for optimization performances, both sides don't need to know, right? That's also very nice. So these are all very good principles that make the whole design of the web easier. It makes it more scalable. It makes it makes it possible for browsers to innovate while the servers remain the same. It also allows servers to innovate while the clients remain the same. So it allows for a lot of flexibility. And the question, of course, is how come that that these client-server instances don't need to know all these things? And one of the reasons is that there is no communication state in principle. So an HTTP response in general should not depend on the previous state. We've seen in the lecture about the HTTP sessions that there are exceptions to this rule, right? So if you do a web shopping cart, shopping basket, where you want to put things in your shopping basket, that's not true. So these type of applications basically violate some of these REST rules, right? So there are exceptions, but in general, this should not be the case. And one of the tricks to make it happen is to have some agreements on types of messages, types of interactions. And one of the agreements is that some operations are considered safe. And if an operation is considered safe, it means that you can ask for that information to be served, and you are sure that there are no side effects. Right? So you can do a GET message to the homepage of the faculty, and if the REST principles are applied, GET is always safe. So it means that you can do that without any side effects. So it will not, by accident, change something on the server side. It will not delete something. It will not update something. You can do a GET without any side effects. And that's different, of course, for a post. Right? So for a post, you expect side effects, and it can also be that if you do the same post twice, you get twice the effect. Right? So if I do a financial transaction and I pay $100 from A to B, and the effect of the transaction is that that payment is carried out. If I do the same post again, because I by accident hit reload or something, you can also expect that that same payment is done again. So that's a post. It's not safe, and if you do something twice, you can also have the effect twice. But all the other methods should be called idempotent, which means that if you do the thing twice, the effect is only once. Right? So if you do a delete, for example, you say delete item 1, you expect a side effect, namely that the item 1 is deleted. But if you do a delete item 1 again, you expect the second time nothing to happen, because delete is idempotent. Is that clear? The difference between safe and idempotency? So safe is no side effects at all, and idempotency is yes, there's a side effect, but only one time. And basically, we agree that all the informational requests, so get and head and options, are safe, so no side effects at all. That all the other are not safe, but idempotent. So a delete and a put can have side effects, but only once. And if you hit the reload button too often because you're impatient, right? It shouldn't make a difference. You can press reload as often as you want, except for post. If you post data multiple times, then you can also expect the effect multiple times. And that these rules allow also the client in the user interface to take care of that, right? So if you do a GET request and you press reload often, your browser will just do the reload often. But if you do a post and then do a reload, you will get a warning of the browser saying, are you sure you want to post this again? Because it might have effects that you don't want. Right? So these are the advantages of having these guidelines. Question?
So with the example you gave, the idempotent, so if you delete like item 1 from a database, so it's sent it twice, it kind of wouldn't work. But then how does that separate from kind of if you sent it and it deleted the first item and then your database kind of everything moved up and there was a new item 1 and then it got sent again and it deleted that? Like,
so the question is, my example was if you delete item 1, item 1 gets deleted, and then again you would delete item 1, nothing should happen. But if item 1 stands for just the first item in your database, right, you would expect the next item to be deleted. You can implement it like that, but that would make your delete not idempotent and not conforming to the REST architecture. There's no REST police that will arrest you for doing this, right? if you violate all these rules in your web server, nobody is going to say you will be kicked out of the web. Because these are all things that we agree on, that it would be better to do it like this. But if there are special cases where you think, okay, I should violate these guidelines, then nobody will stop you. So if you think for my database, delete first is just delete first, and I don't care about these idempotency rules, nobody's going to stop you. But it will be dangerous for clients that assume that your delete is idempotent.
So then these rules are not really enforced by like a browser or any other organization, but rather by the network, because people just won't use your website because it's just too confusing.
I know a lot of websites that violate these rules and are heavily popular.
Okay.
Right. So.
So it's unenforceable.
But I think it's generally unenforceable.
Okay.
But the web developers like it, right?
Yeah.
So in general, things are okay because most web designers that design these websites, they like it because they know if I would be the client, I would like this server. So I also make my services in a way that they conform to these rules.
Okay.
But that doesn't mean that there are no exceptions.
Okay.
It's not a law of nature.
Yeah.
Other questions? So get and head and other informational things are safe. Post is not safe and not idempotent. And all the other methods should be idempotent, and but you can violate all these rules. Right? This simplifies things in a lot of cases. Sometimes it makes things more difficult, right? So sometimes you need extra things like the cookies to do the authentication and to do the things where you do need state. But in general, it makes things simpler. So if we look at some typical HTTP requests, right? So what can you say about HTTP GET? I more or less said it, right? When do you need a GET? What are typical use cases of a GET?
When you access a web page on a server and you want to display it in the browser.
Yeah. So if you want to normal interaction where you want to request an HTML page just for display in your browser, that's a typical GET, right? It's an informational request. You request information. You don't send out information. You don't want to change information. It's just a retrieval action. And is it safe? Should it be safe? In the sense that there are no side effects. Should it be idempotent in the sense that if you do it twice, nothing changes? Yes or no? Yes? Anyone for no? So if you do like a visitor counter, right? You are the gazillion visitor, and then next time you say, oh, you're the gazillion visitor plus one. Does that change the safeness or the idempotency? So a website having that feature, right, is not safe in the GET, and it's not idempotent, right? Because it does change something on the server side, namely a counter is increased, and that counter is increased for every time you reload. So it's both not safe and it's not idempotent. So a visitor counter is a typical example of a site technically violating these rules about GET being safe and idempotent. But does it really matter? Does it make the whole web break down? No, right? But it is a violation of these basic principles. Create a new financial transaction, right? Post is typical. So you fill in the form, right, and you hit submit on your form, and you will do a post. It's a typical use case. Is it safe? Anyone for safe? Anyone for unsafe? It's unsafe, right? It will have side effects because that's the intention. Idempotent or not? Anyone for idempotent for post? For not idempotent? Yeah. Okay. Replacing a specific item, right? This is in your database a typical transaction. That if you interact with a website to change things in your database, what you will do in the assignment 3. Typical HTTP request used for that is put, because it may have side effects, so it's not safe, but it should be idempotent, because if you say, okay, replace A by B, then you expect the side effect to be that A is replaced by B. But if you then again say replace it by B, you will expect that it will still be B. So the second put should be harmless, and the third put should be harmless, etc. So only the first one matters. So it's idempotent. And the same for delete, right? So if you remove an item, typically you would use the HTTP delete message for doing that. If you do it like you said, that okay, I put delete on the first item, and it will delete whatever is the first item, one after the other. It will not be idempotent, right? So the REST principles would say, okay, if you would do this in a REST way, you would not do it like that, but you would say, okay, give me the exact URL of the thing you want to delete, and then that URL doesn't exist anymore, and if you do it again, it's harmless, second delete. So that would be the REST way to do this.
So it's not about these commands having specific functionality, it's about letting people that are going to use your server know what will and won't happen. So the example you gave of replace A with B, and if I use it and I do it multiple times, it's not a problem. But if I had replace A with A times B,
yes,
and I do it multiple times, then it would be different. So then I should make that into a post rather than a put. That's fundamentally what we're doing.
Yeah, so I think the key thing you said is that people can predict what will be happening without reading the documentation, right? That's a big part of this, and it makes it easier to develop web services very rapidly. That's one thing. It also allows clients and servers to anticipate that. So having a warning window when you hit reload on the post is only possible because of these agreements. Because otherwise, the browser would also need to do that with a get or with a delete. And technically, of course, it's possible to do get http://example.com/delete. Right? There's nothing that blocks you from doing that. But you will not get a warning from your browser because your browser doesn't expect this delete to happen in the get. So is that clear? Both from the human point of view, that humans expect what is going on, can predict what's going on without reading the documentation, and that machines can predict what will be going on. These principles are very handy. Okay, so until now we have basically been looking at web servers that respond with documents for human consumption. Right, so HTML documents, videos, audio, images, all intended for human consumption. But that's not the whole story. You can only do that all by using REST services. But I think that the biggest application of REST services is in web services that don't serve content for humans, but serve content from machines. And then these machines serve the content for the humans. Right? So or they serve also content for machines, and then at the end there's always a human in the loop. But there are a lot of services that request data from other services. And they tend to use REST. And of course, that's also the thing you're doing in assignment 3. And it's the thing that you have on the client side be using in assignment 2, right? And we also have seen that if you do this data-oriented services, HTML is not a very handy format, but formats like JSON are much easier to use if you need to parse the data and do something with the data, for example, on the client side. And these examples you see a lot, right? So all the big web services nowadays, they offer these HTTP APIs that conform to the REST principles. And in the lab questions, I want you to look at these examples, not only from the functionality they provide, but also from the type of documentation they offer to teach developers to use this, right? So Twitter wants other developers to use their API to build services on top of Twitter. That's good for their business model, right? And if they want to do that, they need to offer these APIs for free, right? and have enough documentation that web developers are actually going to use that. And one of the things I've learned over the years by talking to web developers don't like to read documentation. Right? So the trick is to how do you give them the minimum information they need, right? But if you provide more, you scare them off and think, oh, this is too complicated, I'm not going to do it. So you need to be very concise, give them exactly the amount of information they need, but nothing more. And I think that's also a good challenge for you in assignment 3. Give the documentation people would need to use your service, but nothing more. It will be good to have an example from this to look at. So I want to use Spotify as an example. So this is from the Spotify developer website where they document their REST API. And they, for example, provide a service where you can get all the data about a specific album that Spotify serves. Right? So suppose you want to build a web application on top of the data that Spotify has. And a lot of sites do, right? If you publish the top 2,000 or whatever, and you want to have links automatically to all these Spotify versions of the songs that you produce, right? It's very handy to have an API to do that automatically and not do it by hand. So there are a lot of developers actually use this. So Spotify needs to document the services in a way that these developers can understand. So what do the REST developers need, right? And we have already seen that. There are 3 things: the URI, the format in which it you can get it back, right? And the methods that you can apply to that. And that's exactly what you see. So the first thing is, okay, what's the URI of the web service? In this case, it's api.spotify.com. Version 1 of the API is version 1, and then albums, and then the ID of the album. So that's part 1. The other part was the method. So what is the method that we can we use? So in this case, if you want to get information, right, it's easy that it's the HTTP GET method that you need to use. And then I expect, the other thing it would be the format, right? Okay, response format. Then you have the key 3 things. Okay, how does the format look like? Well, you can have a lengthy explanation. What people typically do is just give an example. So they just give an example of the format. So what format is this? JSON, right? 99 out of 100 services nowadays offer JSON, so that's a good guess. So if you understand the JSON, and basically they try to make the field names in a way that you can just figure it out yourself from reading the example, right? And then basically you have all you need, right? You have the URI, you have the method, you understand the format, you're in business. This is all you need. So that's for your documentation of your web service. Also, if you put the URI there, the method to use, the formats that are being used, and an example. Most of us, there's one key element that is missing here that I want you to add to this. Anyone? Errors, yeah, error handling. So the HTTP response code, right? So if this goes well, we can expect it's 200. Maybe there's no need to document it, but what can go wrong here, right? There are a lot of APIs that require authentication or authorization, right? So here also you need to do some on the command line if you do to authenticate yourself. Otherwise, you will not be allowed to use the web service. So there are all kinds of things that can go wrong there, right? So I want to know, okay, what happens if I mess up the authentication? It's not very well specified here. So that is something you need to add on top of that in your assignment 3. Think about the error handling and what HTTP response codes you will reply. Right, so when do you do you give a 500 type error or a 400 type error? Think about it. And in the lab, We also do another example. So this is from Twitter. If you want to get information about trends in a specific location, right? So trends in Amsterdam, for example, on Twitter, they have a web service for doing that. And again, right? You need the method, get in this case. You need the resource URL that they give. Some parameters, response format, JSON, with small letters. And then again, they do an example response, right? It's a completely different service from Spotify, right? And for Spotify, it's information about an album. This is about information on trends on Twitter, something completely different. But the structure is completely the same. And that's because they both comply to these REST rules, and they both know, okay, our developers want a URI, a method, and a format, and then they are happy. So the documentation ingredients are almost identical in both services, which makes it very easy to develop services on top of this from a client developer. But it also makes it very easy to add new services from the server developer, right? Because these conventions are the same for all the things they do. Okay, my proposal is to continue a little bit longer and then do no break, but just go home early. Is that okay? Or have a lunch break early. And then there's another lecture, of course, at 3:30. Okay. Because I think we're almost done. Okay, because I think we only need one thing, and that's the practical stuff about Python and Bottle for assignment 3. Is everybody fine with just continuing? Because I think if I need 10 minutes for this and we come back from the break just for the 10 minutes. Okay. Okay, so for the Lifecycle Informatics and IMM students, right, this will be in Python. You should be familiar with this. How many people here did Python in the previous? How many of you passed the course? How many don't know yet because they're still waiting for the everybody? That's because the first exam has not been graded yet. Okay. Who thinks that he has passed the course? Who expects to have failed this course? Okay. So for the computer science students, assignment 3 might be a bit of a steep learning curve, right? So I expect you to play around with Python yourself. If you have never used it before, if you use a Linux box or a Mac, it's probably already installed on your computer. If you're not, if you're Windows, it's very easy to install. There are tips in the assignment and in the lab questions to do so. And I think it's a very good language to learn. They also said that Python is nowadays very, very popular in all the big data and data science applications. For one reason, Python comes with a free number crunching library, NumPy, with all kinds of pre-factored algorithms. Everything you want to do on statistical analysis, machine learning, etc., is available in libraries like NumPy. And also a very interesting recent development is the notion of these Jupyter interactive notebooks. So what people do is they publish on their blogs, they publish what they do in their big data and data science experiments. Right? They write about it in plain English, but within, intermingled in the English, is the real Python code that you can just click run on the website, and it will do the experiment live on the web. And this is now very popular both in academics, but also in commercial research, because people use this to advertise their work, right, in a different way than the old-fashioned papers. And this also made Python very big in this area. So I think it's a very interesting language to learn if you haven't seen it. The fact that Python has no compilation step, we're going to take advantage of that in the assignment, because once you start up your server, the server will check the code for changes, and every time you edit something, it will try to reload automatically, and you have to update live, right, without restarting the server. That works well if the syntax of your Python is correct, and it breaks down if you make a syntax error. Right? So then you need to restart the server. But while you're making small changes, like fixes in the in your strings, for example, these are typical changes that I need to make a lot because I make typos. But they don't change the syntax, so the change that I make syntax errors is very small, and it's very handy that you don't need to restart your server every time. So that's about Python. About Bottle. Right, so yes, this is another framework you need to learn, but it's a very small one. So I think this is one has the quickest start immediately ratio compared to the amount of time you spent on reading documentation. And once you start it, right, you immediately have a real HTTP server running on your computer that you can access by default on this URL. So it starts on port 8080. And if you have this reloader option on, right, it exploits this reload option of Python to do it live. It's all explained in the tutorial. So I come back to my JavaScript comments, right? Do small incremental steps. It makes it so easy, and it makes it so much safe. And the chance that you have 25 errors while you don't know what's going on is just a lot smaller. So we provide example code on Canvas. So who of you already uses Git or GitHub? Right, there will be a GitHub repository that you can use and check out the code. And then if you don't use GitHub and you don't want to use it, that's all fine. You just need to download the material. There's already, if you start the example code that we have, you already have a Bottle web server running on your, so you can just start with that and then make small incremental changes, right? So my tip would be make stupid changes in the beginning, just to learn. Make a typo and see what happens. Make sure that you can restart the server after the typo. Make sure that you can understand the error messages you get. Make sure that you know where the error messages go. So make little changes and just experiment with what's going on. Then make one extra line of code, make a print statement that prints hello world to the console, right? Make a change to the response to the client, see if you can see it in the client. If not, then you know that the changes you make are not updated automatically, so you know there's something wrong. But do a little bit of exploration that you know what's going on your machine. So especially on Windows, what I've seen happening is that there is a web server started up in the beginning, and then people think it stopped, but it didn't. They make changes, start up a new one, right? And in the browser, they still communicate with the old server. And they make all kinds of changes, and nothing makes a difference, right? And that's because the old server is still running on. So also experiment a bit on Windows, in the Task Manager, for example, or in the equivalent on Linux and Mac, that you know if your server is running or not. And so if you do this to server development, that's a really, really important piece of information. That if you shut down your server and you check the taskbar, you should not see a server, right? If you still see a server, then there are multiple servers running without you knowing, and you don't know which server you're talking to. So make sure that you shut down everyone before you continue, because the chance that you are talking to the wrong server is very, very big. Okay, so we talked about database connectivity, right? That you always need this. You also need it in this assignment. So also that code to help you do that is available in the examples. The SQL queries that you need are also available in the examples, right? So all this stuff is not part of the course, but you need it to do the rest stuff. So what I want you to learn from this assignment is all the rest specific things. The Python code, most of it we give away for free. You just need to do the rest things. The database code, how to contact the database in Python, we give away for free. The SQL queries, we give away for free. Try to focus on the REST part. Again, there are a lot of lab questions that provide the little baby steps you need to start up, right? So do the lab questions, and again, really try to conform to this tip. Play a little bit around before you start, right? So if you don't know how to start up your server and then write 25 lines of server code, that's not a good idea. That really makes your life so much more difficult than needed. Please try to take advantage of this. Okay, so there's one more line about the security. We talked about security in the JavaScript lectures. It also applies to the server-side lectures. Right, so programming errors on the server side are a notorious security leak. So one of the things is that because you're now on the server side, you need to think about, okay, what's an evil client side? What could an evil client side do with my service? So if you're updating your phone database, right, and you take as input the brand of your phone, you expect your users to put Samsung or Apple or something like that in there. But what if they do something completely different? So what if your client sends you an update or a post to your database with your phone model, and the phone model contains 100 kilobytes of HTML and JavaScript? Would you just put it in the database? And if then people ask it, you just return it back and it will be put in the client, or not? Right? So these are the different types of questions you need to ask if you're on the server side. And of course, if you only reserved, so in Python this is not an issue, right? But you can imagine if you only reserved a little bit of amount of space for your phone model, and this amount of space, this buffer overflows, all kinds of bad things can happen on your server. And there are a lot of security leaks that exploit these errors. Right? And especially with open source software, it's very easy to hackers to recognize these errors. It's also easy to fix them because it's open source, but it's also easy to recognize them if they're not fixed. And this is an advanced, not often occurring security leak. So be aware of that. Another leak is that giving away the errors on the server to the client is also seen as a potential source of information for hackers that servers don't want to give out. Right, so you will see a lot of these web platforms by default give you no error messages at all to the client. So you need to be aware of that. For example, in Bottle, all these debug messages are by default turned off, and you need to turn them on explicitly if you want to see them. So also be aware of that. There is this famous quote, right? On the server you can do anything, so you have great power, but with great power comes great responsibility. I think that's a good way to end this class. Good luck with the assignment. So the next lecture will be about web science. If you didn't read the web science article in the reader, maybe you can do that after lunch. And then good luck with the assignment. Sorry. In week 3. Did I screw it up?